थोड़ा
for the maritime autonomous surface ship, which is also known as MAS. So the contents of my seminar are and applications, challenges and limitations. So the title of the project is the development of a versatile and fast algorithm for ship routing system. And the project domain is artificial intelligence and machine learning. My project group members are Arjun, Ajinkya, Krishna, and me. So the motivation behind this problem setting. So what is the problem? Ship face the problems in seas. Sometimes so sometimes marine fouling means sometimes they are carrying the oil or other containers big of leaks, so that's why the which faces the environmental impact on the sea animals. Also the when more fuel which is one which costs to the more cost, and that's why when the more fuel which is one which leads to the more pollution. So why this problem? There are these two effects because of this. One is the environmental impact and the second is the economical impact. There is first the environmental impact, which is the ships release the greenhouse gases like CO2 and other, which increases the sea pollution and also provides the harm to the marine life, which leads to the extinction of the marine organisms. And the economical impact, which is the ship company spend millions of dollars on fuel and maintenance. So the problem is that the shipping industry requires an efficient and adaptive system for optimal ship routing. There are traditional methods are also there, but the dynamic method is not there. For that, we are going to develop a website on that, which will result in the considering real-time factors like weather, the tides, speed, and also the navigation and sea port condition also. The aim of the project is to develop the fast algorithm for optimal ship routing, which minimizes the fuel consumption while considering parameters such as travel time and road safety. So the objective is to develop the algorithm first. They are using the SCAR algorithm for that, which calculates the minimum distance between the two ports. The second is to minimize the fuel consumption. For that, we are going to calculate the tide speed, also the weather conditions in different areas. The third, to reduce the travel time by ensuring time and efficient shipping. So the project title and the seminar topics has explained out. So the introduction to the maritime autonomous surface ship. The marine industry is planned towards the shipping 4.0. So what does mean by the MAS? MAS is maritime autonomous surface ships, which are the vessels which are capable to work on the water surfaces without need of any human intervention, which are equipped with the various sensors and technologies which are used for the routing. There are two types of the MAS. First is the fully autonomous, and the second is the partially autonomous. In fully autonomous MAS system, all the control is automatic, and in partially we need some crew or human intervention for that. So which will ensure the efficiency. And the challenges there are various challenges why this. The first is the legal authorities. The legal authorities have implemented various rules and regulations on the ship routing. Second one is the cyber threats or cyber risks. Sometimes if the malicious software or anything has happened on that, so the breach will happen and the whole control of the ship goes towards that the malicious software, which leads to the economical impact and also the some bad usage. So what is the need for risk analysis? the first important point for the risk analysis is safety. Safety is the most important point. And safety also the user acceptance. If the system is very the main for risk analysis, the main point for the risk analysis is safety. If you provide the safety to the ship routing, all the luggage or containers go to the our place safely. And transition from human operators to autonomous system into the system is necessary comprehensive risk analysis. So the methodology has been given by the flowchart. So phase 1 is design requirements and assumptions. So for second is instruments review, third is configuration setup, phase 4 is risk analysis, and fifth is critical analysis. So we are going to discuss about the phase 1 design requirements and assumptions. So the design will be assumptions like we are going to assume like the data which is going to receive is the real-time data so that we can process and take the decisions like whether we are going to forward or stop at that point, or what are the environmental conditions in our room. So second is the instruments. We are going to use the 5 main instruments. First one is radar. The radar which calculates the speed of the ships and the exact positions of the ships in the sea. Second is the lidar, which provides the 3D images on the positions of the ships. Third is the cameras, which calculates the speeds of the other ships. Also the mass of the other ship. There is also chance of collision of the masses by 3 ways when overtaking or while coming towards each other or passing from each other. Fourth is the infrared sensors, which calculates the heat of the environment and which maintains the engines of the ships. And fourth is the ultrasonic sensors. Third is the configuration setup. We need to configure some setup. In port, we need to analyze some parameters such as port infrastructure, port size, port condition. In ships, we need to assume some parameters such as ship size, ship density, and how much material it will contain. So develop baseline and component level configurations. Also the weather will also affect in this. So fourth is risk analysis, in that we cover the risk analysis. Fourth is criticality analysis. Identify the critical components and key design points, and that key design points will be given to the designers so that they can develop a better system which can be integrated to all the users and can be used to access the availability of risk reducing measures. So IMO instruments. IMO stands for International Maritime Organization, which is US-based, which gives all the rules, which sets all the rules and regulations for this all the marine operations. First is the situation awareness system. It acquires all the necessary state data of the whole ship, means the data between both the ships in the sea is getting transferred. By using this, we can use by using this data, we are going to take decisions about whether to go next or not. Second is decision making system, which is assess the collision risk and makes the appropriate collision avoidance decision. Corresponding to action numbers means which gives the instructions to the crew members, and they take the decisions on that. Third is the communication system, which communicates the mutual evaluated intentions, emergency or dispute between the voice and PS. And fourth is the action execution system. So this is the we are going to consider all these factors in this project. what are the applications? Navigation efficiency, fuel consumption management. For fuel consumption management, we are going to calculate the wind speed, tide speed, which for the by calculating this we can calculate the minimum amount of fuel we are going to require. Safety enhancements. For safety enhancements, we are equipped with the various sensors, environmental protection and emergency response. So the conclusions, which are the objectives achieved with the approach and the fault analysis. In fault analysis is the we are going to if there is one problem, we are going to solve that by Boolean logic, and which provides the robust framework. So what are the objectives we achieve through this project? So our safety is increased. Also it ensures the efficiency and fuel management. So these are the references.
Specify the name of algorithm.
We are going to use A star
Working.
algorithm.
Which?
A star.
What did you understand from this paper?
And about the mass, maritime autonomous surface ships, about the fault analysis, and the fuel consumption and all about the routing system. Collision avoidance is the main topic from this.
You are working on which objective now?
First,
First. Fast.
And
Develop a fast and efficient algorithm for the.
cheaper.
This paper is not related to your topic, I think. It is the risk informed collision awareness. But you are going to find out the minimum route. Okay? So check another paper also and meet me once. नंतर मला भेट पेपर घेऊन ये. ते ओशनचं जे जर्नल आहे ना त्याचेच पेपर असतात सगळे याचे. एल्सवेअरचे तू एखादा अजून दुसरा पेपर घेऊन माझ्याकडे ये.